Hey, if you're studying for your final exam for your first semester in Algebra 1, this is a practice test for you. The way I've got it all set up is there's 35 questions. I'm going to do a flip through first. Each question will be on the screen for 3 seconds so you can pause and try it. And when the flip through is done, I'll meet you back here and we'll go through all the solutions. Good luck with this practice test. I'll see you in a minute. If you took that as a practice test, good job. Let's go through these solutions quickly. You see something like this, 10x. 10x means 10 times x. There is a number multiplied by 10. If you make this mistake quite a bit where you're not sure whether you're supposed to multiply, divide, subtract, go ahead and take a look in the video up in the corner about these most common algebra mistakes. This is a big one. But you are supposed to divide. So we'll divide both sides by 10 and we get x equals 6. Number 2. For this one, we want to add 7 to both sides, and we get x equals negative 10. Number 3. This is a tricky little thing. People do make mistakes with this one as well, and I went over that in that other video. But what I'm going to do with this one first, I'm going to add 9 to both sides and get that x over 2 by itself. Then multiply both sides by 2 to clear that fraction. Our answer is 20. Another one of these like weird little fraction problems, you need to clear that fraction first, multiply both sides by 4. And when the numerator just comes down, so we end up with 2 plus x equals 8, subtract 2 from both sides, our answer is 6. This one is going to have to start with distributive property. Very slow. Okay, then subtract 56 from both sides, and we're going to end up dividing by negative 7, and we get x equals to negative 8. All right, this one has a lot of stuff going on with it. We're going to start by simplifying some terms if we can. And there's the full solution, x equals 3. Number 7, how to start here. Well, we're going to start by adding 3 to both sides. Here comes the full solution. Number 8. This is called a literal equation. I'm going to let this sit here for a second while I explain. A literal equation has it can have some numbers in it. This one has all variables. But when it says you want to solve it for x, in this case it's telling us to pretend that x is the only variable and pretend that z and m are numbers and work with them like that. So in this case I added m to both sides, and that's all I needed to do to get x by itself, which is what we are asked to do. An absolute value equation. Well, absolute value equation actually has two meanings. The thing inside the absolute value bars either equals +1 or equals -1. So I wrote those both out, and we're going to solve both of these equations, and how we solve them is the same. We're going to multiply both sides by 3. So when x over 3 equals 1, multiplying both sides by 3, we get x equals 3. And the other one is going to be -3. So those are our two answers, 3 and -3. All right, this is it's not an equation, it's an inequality, but you solve them like regular equations. I'm going to start by adding 13 to both sides. So there is your full solution, and there will be times where you need to flip the sign. I'll go over that when they come up, but this one, not so much. This is one where you will need to flip the sign. When you multiply or divide by a negative number, you have to flip the direction of an inequality. Here comes your solution. And here comes the sign flip right there. So instead of it being less than or equal to, it needed to be flipped to greater than or equal to. And that again, that happens whenever you multiply or divide by a negative number. Adding and subtracting does not do that. Adding and subtracting negatives, you just, keep the sign the same. Number 12. Again, inequalities look a little more confusing, but you start them just like equations. So we're going to add 2 to both sides. Here's your solution. No sign flip here. We ended up dividing by a +3, so everything is fine. Number 13, okay, we have an absolute value equality, and here's what I like to do to make sense of these. I like to set up a little number line and kind of sketch out what I'm talking about. If the absolute value of something is greater than 90, then it means the something has to be obviously greater than 90, or that would be up here in the upper part, or less than -90, because the absolute value of 100 would also be bigger than 90. Absolute value means it's just how far away from 0 it is. So now that I have this set up in my mind, then I know how to set up these two inequalities, and I solve both of them. -10x less than -90 has to do with anything that's down here in this neighborhood. Divide both sides by -10. And that's x, and that's a 9, but the sign needs to flip because I divided by a negative number. The same thing's going to happen over here. I'm going to divide by that -10. And there's our sign flip. So the correct answer is B. Writing the point-slope form of an equation. Well, the point-slope form is this, and it uses x1, y1, and m for the slope. So I'm just substituting in the numbers, and there is your full solution. But one of the things to keep in mind is when you are subtracting x1, you're subtracting -2. That creates this double negative thing in the middle, which changes to a plus. So in point-slope form, it's just y minus 2 equals 3/2 times x plus 2. All right, we are going to write an equation for this in point-slope form too, but you're starting with 2 points, which means you need to start by finding the slope. There's the point-slope form, but to get the slope, we need another formula. We're going to use both points, and we're going to move that slope into the point-slope form. Okay, the 1 The first one, the red one here, is coming from y1. Y minus y1 equals -1 was our slope, and that goes into the slope spot. And the 3 is the positive 3x1. And that is our equation in point slope form. You do not need to multiply this out, but you'll notice when I chose my answer, it didn't say -1 in the front, it just has a negative, same thing. All right, slope-intercept form is a little bit different. That's using y equals mx plus b. I'm giving you an equation that's in point slope form. I need you to simplify it so y would be by itself. If you look at all these choices, with the exception of b, y is alone. So we're just going to do some algebra and simplify. And here it comes. There's your solution. Y equals 3x minus 5. Whoa, okay. That's okay. Here's a look at the solution. We're doing the same thing again, except that I needed to find the slope ahead of time. And we ended up with a double negative thing happening again. You might want to pause this or screenshot this and take a look at your work and compare it. And there we go. Oh, that doesn't look right. We're going to have to pause this. Number 18, we're going to put this in standard form, which is ax plus by equals c. Basically, standard form is all the stuff with variables is on the left side, and there's a constant on the right side. But in this case, we're starting from the very beginning with 2 points. I have to start with slope, use point slope form first to get some kind of an equation, and then I'll move that equation around with algebra to make it look like this. So starting with slope, x1, y1, x2, y2, pull out the slope formula, take care of the double negatives, and there we have our slope is -1. Now I'm going to pull in point slope form right now, and I'm going to use the first point. There we go. All right, so I had y minus a -3 equals -1 is the slope times x minus a positive 4. I used this first point. The double negatives turn into a plus, and then when I run the distributive property through on the -1, -1 times x is -1x. I just wrote -x here, and -1 times -4 is a positive 4. This is not in standard form. I need to add the x to both sides, and I need to subtract the 3 from both sides. I'll do both of those in one line to save space on my slide. So we end up with x plus y equals 1, and that is answer D. All right, sketch the graph of each line. Obviously, this is multiple choice. You're not really sketching anything. When you take your final, it's on paper, you'll be able to draw on that. But right now, I just need to figure out which one of these would be the graph for this. So I go back to y equals mx plus b, which is my slope-intercept form of the line, because this one is actually, I think, the best version for being able to look at graphs and figure out what's going on. That y-intercept is +1. Well, I'm going to each one of these choices, and I'm going to put that +1 dot on there. This is y is +1 right there. Now, when you look at this, there's only 2 of my choices that actually go through that y-intercept, so I can eliminate these guys. They're not going to be an answer. Now from here, b is going upward, which means that's a positive slope. D is going downward, so that's a negative slope. So if I were in a hurry on my final, I would go ahead and choose D right now, because this is a negative slope. But if you want to double check it, this slope has to go down 1 over 5. I'll graph that on each one, and you'll see which one works and which one doesn't. There it is, D. And we're doing that again. The y-intercept is -1, and the slope is +1. Let's get that -1 intercept sketched on each one of our choices. Let's eliminate the one that doesn't actually go through that point, but all the rest of these do. So this one's going to come down to the slope. Well, the slope being positive 1 means you're going to go up 1 over 1. Let's put that on all the graphs. Up 1 over 1, up 1 over 1, up 1 over 1. And the only one that actually lands back on that line is A. This is our correct answer. Intercepts. I love intercepts. They're super fun. Okay, if the x-intercept is -2, that means we're going to put a point on the x at -2 for all of these, all of them. If the y-intercept is +3, then we put a dot on the +3. And our answer here is the graph that goes through both of those points, which is D. Okay, now for this one, you could use intercepts again, but since y is all by itself, I'm going to just subtract the 3x. And so I have this thing in slope-intercept form right now. Y equals -3x minus 1. So I know the y-intercept is -1. And that is here on all 4 of my graphs. So these two, C and D, it doesn't even touch the right intercept. So I can get rid of those. I'm looking at these 2 graphs here. Again, my shortcut without graphing slope would be to just know that when a line is going uphill, like A, that's a positive slope. When a line is going downhill, negative, that's a negative slope. So I would choose B right now because these are my choices. But for those of you who like to count it out, a -3 slope means you're going to go down 3 over 1. I graph it, and you see which one works, which is B. Oh, fun. Horizontal and vertical lines. Well, the simplest way to think about this is just realize this is a line, x equals 1, but it's also a point, and the line has to be going through that point. So if I put that point on all my choices, I only have one line that's going through that. It's up and down, going through the point, x equals 1. C is the choice here. Now we are given a picture, and we have to write an equation for this picture. Well, we don't have to write it from scratch. We know it's going to be one of these. I like looking at the y-intercept first. It's right here at +3. I have 3 choices, which means D, bye. All right, it's going to be one of these 2. Now for, without getting into it too much, I've got 2 positive lines, 2 positive slopes, and 1 negative slope. This line is moving uphill. It's moving positive. So I'm going to just get rid of C right now, eliminate that as a choice. Okay, now if I look at A and B, both of them have a run of 5. I know this point is one of them. If I go up 4 or up 3, I'm coming off the graph. But if I back up 5 and go down, I land at a point which is right here. There's no other point on this line. There's some that get really close to the corners, but not good enough. It's right here. So there's my slope. I am going up 4 and over 5. You don't even really need to count out the 5 because it's 5 in both. My correct answer is A. All right, going through a point in parallel. I try to do these without having to do a ton of work if I can help it. Here's what I know about parallel lines. Parallel lines have the same slope. So I look at the equation they're giving me. It has a slope of 1/4, and I know that the line that is parallel is going to have the same slope. And of my choices, I only have one choice that has that slope, so I'm going with it. If you have more than one, you would have to use this slope and this point and use the point slope formula and work it all out until you came up with a new equation. the way things go, you're probably going to have something like that on your final and you'll have to work it out. But in algebra, sometimes it can be just enough for testing the concept. All right, perp means perpendicular. Perpendicular slopes have opposite reciprocals. They're not equal, but there is something that's going on. You need to, if you don't know what these mean, that's the thing, right? Opposite means you're going to change the sign. In this case, the negative 1/6 is going to change to a positive, and reciprocal means you're going to flip it over. So 1/6 is going to flip over to 6/1, which is a 6, which is why the computer checked C as an answer before I even finished talking. Number 27. Okay, now we're doing functions. And this is just a yes or no thing. Is this a function or is this relation not a function? And the thing you want to look for, mappings are great for this. You are looking for a place where you have any x values that are going to 2 or more y's. If you thought of this as a machine, if I plug in a -4, I'm supposed to get a 5 back. There's no confusion. If I plug in a -2, I'm going to get a 7 back. No confusion. If I plug in a +5, I'm going to get a -7 back. No confusion. Everything's working smoothly. Except for this 4. All of a sudden you plug in a 4 and the machine's like, I don't know, do you want a -3 or do you want a 1? When you have that kind of confusion, you do not have a function. Functions are supposed to give you answers back. All right, another way that they could give this to you is in a table format, and some of you are going to be able to eyeball it. If it's confusing, and I like to write out the maps, but I don't necessarily draw the balloons. I go with something like this. -2 is going to 7, -1 is going to -3, 1 is going to 3, 2 is going to -4, and 4 is going to 1. In other words, there is no repetition, there is no confusion. This thing is a function, yes. All right, again, yes or no, is this a function? Well, they have a bunch of dots. They didn't connect the dots, but that's okay. When you see a graph like this, you do something called a vertical line test. And so you'll probably just use a side of a piece of paper and line them up. Just line up edges of your paper on all of these dots. If you see 2 dots on the same vertical line, that's confusion. That means for the same value of x, there is 2 answers. But if you are sitting here and you say, well, if x equals 3, I'm right here, and the answer is 2, there's no other answer given, which would be the y values, then you're good. So to say that another way, if you do the vertical line test, let me back that up so you can see. Run the vertical lines, and if there's only 1 point on every vertical line for that value of x, you're good. That is a function. All right, solve each system by graphing. This is pretty easy. All you're going to do is graph 2 lines on the same graph and see where they cross. So I'm graphing this first line. It has a y-intercept of -2. It has a slope of -1, so I went down 1 over 1, put a dot, then I drew a line. Now I'm going to do the other one in a different color. It has a y-intercept of +2. The slope is 1/3, up 1 over 3. Draw the line. And they are intersecting right here. And the value of that, or the coordinates for that point, are -3, +1. So the answer is A. Solving by elimination. This is where you try to cross things out. You put them together and you try to cross them out. So I look at these 2 equations and I put them on top of each other. I can see that the 7s are going to cross, the 7x's are going to eliminate. Whoa, there's the whole solution. 4y plus 2y is 6y. 28 and -28 became a 0, so 6y equals 0, which means y equals 0. And then I plugged that back into one of the equations, solved it for 4, so my solution is x equals 4, y equals 0, D. All right, we're going to solve by elimination again, but this is one of those situations where something just doesn't work. I'm going to take the bottom times 2. If I take the bottom equation times 2, this will turn into a positive 20x, which will cancel with the negative 20x. And I rewrite that. I squish them together. All right, the 20's canceled out. The x's canceled out, but the positive 2y and the negative 5y left me with a negative 3y. 42 minus 15 is 27. Negative 3y equals 27 divided by negative 3. So I've got y equal to negative 9. I have two choices for that, B or C. I do need to know what the x is. So I'm going to take that negative 9 and I'm going to pop it into one of the equations and solve. There it is. The answer is C. I'm going quick on these on purpose. I don't want a very long video, so you're going to need to pause and look at these solutions and take some screenshots. Solve each system by substitution. Well, substitution means you take one of the equations and you put it into the other one. You just smash them in there. It's going to be like a little Twinkie, you know, like a stuffed pastry. We're going to take one function and stuff it inside of another function and solve this equation. So since this one's already solved for y equals 6x minus 4, I'm going to just replace the y in the second one with that. I'm going to do distributive property real fast and start to simplify this. And I get, distributive property got me to the negative 24x and the minus 16. Negative 3 and negative 24 is negative 27. Add 16 to both sides, and we end up with 0 over there, so x must equal 0. Now, I've got the x equals 0. I need to figure out now what the y is. And we just pop that into y equals negative 6x minus 4. If x equals 0, y equals negative 4. So our answer is A. All right, number 34. Here is the full solution. I did substitution again. Obviously, the answer is B. I went right through that run like instantaneously. The only thing that's different about this one than the last one is that neither one of these equations given to you was actually solved for one of the variables. So I just solved this one that has a single y by subtracting 3x from both sides, and then again shove that in there. Came up with a delicious answer of 2, and I didn't even have to plug it in. I got x equals 2, and this was the only one that had an x equals 2. If you're taking a multiple choice final exam, time is an issue. If you can choose the right answer without having to do the extra step, do that. All right, the last problem we're doing is this guy, and this is a system of inequalities. Again, it's a complicated little thing to do. I start by looking at what I've got. And if I start with y is less than or equal to negative 3, and I know that this is the line y equals negative 3, and then I've got two choices that have that horizontal line. The other two don't. So, okay, that one's gone, and that one's gone. So now I'm looking at these two choices, A and C, and they seem identical. You have to look very carefully. A is shaded right down here in this little corner, and B is shaded on this side, has more of it shaded. Both of the shadings are below the y is less than or equal to negative 3, which they're supposed to be. But they also need to be below this other line, which we assume is graphed correctly since I only have those two to look at. So you need to think below. It's less than. And this can be a little tricky. So I have this little diagram to help me out here. Above the line would be if you kept going and got bigger and bigger and bigger answers, which side would you be on? You would be up above here. Below is here. So I need to find the place that's below the slanty line. Well, if I look at A, on the slanty line, I am shaded to the above side, so A is not going to work. And C, I am shaded below on both. That's above. And over here, I'm shaded below that line. I'm shaded below both lines, actually. So C is the correct answer. I know we went through that pretty fast. Hopefully you can go back and pause, replay, and watch some of these again. If you have questions, go ahead and leave them in my comments. If you'd like to check out some of the other videos in this playlist because you need to dive down into any one of these topics a little bit more, here is my algebra playlist. Thanks for watching, and I'll see you next time. Bye. Oh, and good luck on your finals.